Okay, it's starting to level off now. So I'm just going to say a few words then to open the event, and then I'll get out of the way for Andreas. Hold on a sec, just share my screen. Right, so people can see my screen. Good, okay, right. So I'm just going to say a few words then about the London Java community. And just a bit of background for those that are joining us for the first time or those joining us from around the world. So the London Java community, the LJC, or the London Java user group, it's a very well established and highly active group. So we've been running for 13 years now. We've got coming up to 7,500 members, just under, I think now, and we're actually over 600 events now. So yeah, very well established and very active. I think we've run something like 30 events in lockdown on these virtual events, so it's really helped us open these things up. But beyond the numbers, what the LJC is about and has always been about is kind of true community values. There's a reason why it's called the Java community. And trying to bring people together, learn from each other, and mentor and help support everyone to try and get ahead. There's a lot of good things that have come from people coming together. Adopt a JSR, adopt OpenJDK, loads of other initiatives that have come from the LJC and from the people that have been involved in organising things. So yeah, if you want to get involved with anything, please feel free to join and please get involved in the events. So as for who I am, my name is Barry Cranford. I'm the founder of the LJC. I'm not actually a developer myself. I am in fact a recruiter, I run a recruitment company called RecWorks. Okay, the next slide. So a few words about who we are, what we believe, and what we stand for. So we believe that recruitment can be, or recruiters can be, a force of good in the industry beyond just getting people jobs. So basically, if there are people out there that want to learn and there are people out there that are happy to teach, we have the network to put things together. And that's really what we try and do. So we see our work as sitting somewhere between giving back to people we have worked with and paying forward to people we hope to work with at one point in the future. A few examples, we've organized the events within the LJC. We've organized over 2,000 one-to-one introductions between mentors and mentees. And we've run events for graduates, students, CTOs, worked with universities, everything across the whole spectrum. Most recently, we've started a new aspiring speakers group to try and create the next Andres and next generation of speakers, and a real diverse generation of speakers within the LJC and within the tech community. If you have even a slight bit of interest in getting on the conference circuit, in elevating yourself in your own place of work or in anything, hit me up on LinkedIn, on Twitter at BCRecWorks, and I can get the wheels turning on that. It's all completely free. Everything we do is all completely free. It's all powered by recruitment. So we don't make any money from anything we do other than getting people jobs. So if anybody is looking to hire, anybody's looking for a new job, anything at all, then you can always come find us. Okay, so on to today then. So we've been joined with Andres Almiray. So Andres is an open source developer for the last 17 years. He is a Java champion, the co-founder of Hackergarten, and he loves to hack on code and share experiences. And it's interesting today because we've been talking about what topic people should pick as their first talk within the aspiring speakers. And people are saying, come back to, it doesn't have to be the latest shiny thing. So yeah, so it's a nice, interesting one today on what I wish I knew about Maven years ago. So with that, I will hand over to you, Andres.
Well, thank you very much, Barry. And thank you everybody else for joining today. I know that it's lunchtime in UK time. I'm actually streaming directly from Switzerland, so one ahead. So lunchtime it's already gone for me. And I really appreciate the work that you, Barry, Dominic, and everybody else from RecWorks have done to run the LJC for so many years. You have said that the LJC helped with Adopt JSR, Adopt JDK. They even became the first user group that was a member of the Java community process. And that had changed and shaped the future of Java in a way that it wasn't even possible before. And it's all just because all of you have banded together and really care about the community. So kudos to you for doing this and continue to doing so. Okay, so let me see, can I share the screen? And so it'll be the second desktop. And you should be seeing a terminal now. So I'm going to play this slide. So please let me know if you can see the title.
No, I can't see anything.
Not yet, not yet.
Not yet? All right. Oh, I know why. Because I didn't click on the blue button that says share. Now you should see the slides.
That's it, yeah.
Excellent, perfect. Technology, how does it work, right? Okay, so what's going on? What I wish I knew about maybe years ago. Okay, so we're gonna skip the next slide because this is the boring one. This is about myself. I love open source, and this is the reason why I like to talk to you about the experiences that I had across the many different years that I've been in this industry. So when I started, well, almost when I started my career back in college, this language appeared exactly 25 years ago. And when it did so, we didn't have any additional tools for building Java projects other than the Java compiler. While projects were small, this was fine. But once we started to build bigger projects, then the need for a build tool became very apparent. At the time, we had the tools that were coming from the C and C++ landscape. So naturally, people went and gave it a try to make. But it wasn't really what we needed because Java gave us a promise of write once, run everywhere. So we needed portability. Make is kind of like a portable tool, but you still have to have some things that were not really what we wanted with Java. So the band of developers came together and created Apache End, specifically to build the Tomcat project. And for a while, things were fine. I mean, despite that it was XML based and that you have to pretty much redefine the structure of every project for every single thing that you want to do, it worked out pretty well. And it enabled us to write even bigger projects. And eventually we reached another point where it was too many things that we needed to take care of, that we needed a different project to build these things. And that's where Maven 1 came out. Maven gave us as predefined application structure, convention over configuration, dependency resolution. So we didn't have to add those pesky jar files into our source control system. We just can simply rely on some magical metadata, the POM format, to define our dependencies. And then whenever we build, then the build tool will figure out from where to get these dependencies and construct a dependency graph and make things work. Or at least that was the promise. And for a while it worked. And well, there's a little bit of XML in there, of course, that's not really much of a problem. But given that the way that Maven evolved, there were some people that were not really happy with it because Maven provides, in the eyes of these people, a very strict and very fixed structure. They needed to break out. They wanted to have more possibilities to build projects. And that's how this other project came out to be Gradle. And this is where I entered because I discovered Maven when it was Maven 1. And I don't know if many of you remember what Maven 1 was. I don't think that there are that many out there because suddenly Maven 2 came out and that's pretty much what you know today, even though the latest version of Maven is 3.6.3 and a few things have changed. So when Gradle came out, this was back in 2008, Maven 2 was still around. Maven 3 came out in 2010. When I did the switch from Maven to Gradle, I completely missed out every feature that was coming out from Maven 3. I thought that Maven was a simple tool that had an XML-based DSL and it provided the features I described before, and that was it. There was nothing special about it, but actually that is not true. And that's exactly the reason why I decided to present this session because I went back to Maven after spending time in Gradle to figure out if there were features that I missed, if there are features from Gradle that can actually be found in Maven, what features are unique to Maven actually make more sense if you want to stick around using Maven. I should also say that whenever you have any questions, feel free to ask them in the chat and I will try to answer them right away. Otherwise, we will still have time at the end for questions. It may be the case that some of the features that you see today, you are already familiar with. I don't expect that. I really hope that is the case. But it also may be the case that some of these features are completely new, and then this is precisely the session for you. So let's start with the easy things. The first one is how to override project properties. Now, properties for a build can be defined in a couple of ways. You may define them on the command line using the -d command line flag. You might define it in a properties block inside your POM file, whether it is your consumer POM or inside a parent POM or somewhere else in the POM hierarchy. Or these properties can also be defined by plugins. Pretty much every parameter that is specified in a plugin can be reached or configured by a property out of the box. This is something that I really like about Maven. There's nothing as a plugin author that I need to do, and I need to write on the descriptors to expose these properties. So it doesn't matter how you expose them, those properties are ready for you. And one good thing is that you can override these properties in the command line flag. So let me show you a quick example on this, and I hope that now we can see the terminal. I'm going to switch to a project. Let me show you this POM file. It's a very trivial POM file that contains the Maven coordinates, the group ID, artifact ID, and version, which henceforth will be known as GAP coordinates for group artifact and version. And this POM contains just a simple dependency, commons link, and I believe this is an executable project. So if I were to look inside the single source file that this thing has, it's a sample application that prints out hello world, nothing more than this. Now, I've showed you again the POM file, there are no instructions on how to run this thing, but there are plugins that I can run. So actually, no, before I do that, I want to show something else. Which version of Java I'm using right now? I am using Java 1.8 update 191. So that's not the latest version of 1.8, but it will work. And which version I'm using? I think I'm using 3.6.3, the latest one. Perfect. All right. So with this in mind, if I were to do a compile, then I will expect my class file to be Java 8, isn't it? Let's see if that is true. We can quickly do Java P, it's -p, -s, -b, I think, on target classes, con acme sample class. And let's look at the first 10 elements. And what do we get? Oh, that's the wrong command, sorry. It's not -b, I think it's just that. And is that the right thing? Come on, where's the enter key? There we go. Okay, so we're missing, I don't want that. I think it's -c. Oh, hold on a second, I think it was -b, right? There we go. Major version 52. Okay, so this is definitely Java 8. I guess I had something already running quite weird here, because what I was supposed to happen here is this should have been 49 because the default version is Java 5. But if I want to change this to something else, for example, I want to change the compilation to be something like Java 7, then I'll have to say Maven -d for property. Maven compiler source, like this, equals 1.7, I -d, Maven compiler target equals 1.7. I just do a clean to be sure that nothing is wrong, and then do compile And when I do the Java P again, now get version 51, which is Java 7. So what just happened here is that these properties that are defined in the command line, Maven compiler source, Maven compiler target, are exposed by the compiler plugin. And I could redefine them in the properties file, I mean the POM file using the properties block, or I could use it like this if we want to test out a theory. So this is a good thing. And again, it doesn't matter how you define these properties, you can always redefine them in the command line. Okay, let's go back to the slides. Here's another one. This is something that I also really like. You can invoke any plugin on a project based on passing the full gap coordinates and the goal, and perhaps any additional parameters that this goal requires. You don't have to configure the plugin in the POM file in order for this to work. The only thing that you have to have is the means to resolve the artifact for this plugin. So if the plugin is already available from Maven Central or any other repository that you already have configured in your Maven settings file, then this thing will work. Now you have to be sure that you specify the full gap coordinates, the goal, and any additional arguments. So in the example here that you see in the slide, I want to apply the echo plugin. So I need to specify the group ID artifact and version that I want to target. Echo will be the goal. And then echo message will be the additional arguments that this goal takes. Now let's see an example here. And I remember that I said that this application is actually an executable application. So how can I tell? Let's see. I have a series of commands, so I can type it out very quickly and say that I want to execute this class. I want to execute this application. So what do I do without touching the POM file? I can apply the exec Java plugin and invoke the exec Java goal. And in this case, just Java. So I have to simply say the group ID, which is that bit, and the artifact ID, exec Maven plugin, and the recurrent version is 160. The goal will be Java. And if I don't specify the property except main class, there will be a failure because something is missing. So there's a good thing that I can override the arguments using these properties. So if I execute that command, pass it to a shell, I think, yes, this will work. There we go, the hello world. Now there are a few plugins out there which Maven is aware of the, for the group IDs and the artifact IDs. And you can skip defining the full group ID and the artifact ID. So for example, for the exec plugin, which happens to be one of those, you can simply say the short name of the plugin, the goal, no version, no group ID, no artifact ID, and the additional properties. So if now I execute this command, I should get something similar in the past. There we go, hello world. So how do I can show that it actually works for any other project or any other plugin? So here is the third command that I have. This one does execute the echo plugin. So I need to pass the full gap coordinates. And let's see that. And what's going on here is that the first time that I execute this plugin, you see that Maven finds out that I don't have the required artifacts on Maven local. So it goes around and downloads to resolve the dependencies, executes the plugin. I see something like hello world from echo plugin. When I execute the same command again, and I just get the execution, there's no additional download because the artifact, the plugin itself is already found in Maven local. So that's a pretty good thing. It just works like if you were a regular plugin configured in your BOM file. Moving on. Dependency resolution. This is something that is great for Maven when you are looking at the past from the projects that we came before Maven, but it also has a few issues, a few wrinkles, and it's pretty much has to be done with what are the rules for resolving dependencies. Now, I thought that I had those rules cleared out, but as it happens, that wasn't the case. So dependencies are defined in the dependencies block. This everybody knows. And these are known as direct dependencies. You may have additional dependencies in your dependency graph, which may come as part of the transitive closure of your dependencies. Say you depend on, what will be a good example? You depend on Google Juice. And Juice pulls in Guava as a transitive dependency. Now, the rules for resolving dependencies are more like this. When you have a dependency on your POM explicitly defined there, then that is going to be picked up. If it's not there in your specific POM, then it's going to be looked up in the parent hierarchy, if it's explicitly there. And if it's not found there, then Maven will try to resolve it in the transitive hierarchy. And it depends how many hops does Maven have to do in order to find that particular transitive dependency to figure out who is going to win. So if you have Guava somewhere in your dependency graph, and from one transitive branch, you can reach it in 2 hops, and from another transitive branch, you can reach it in 5 hops, then the one is on the 2 hop is going to win. And get this, it doesn't matter if that one has an older version or smaller version than the one that is in 5. The one that has less hops is going to win, and that's the key. So a few weeks ago, I think it's a couple of months ago, I ran a quiz and with 14 questions on how dependency resolution works. And I'm just going to show 2 questions because these 2 were quite interesting. Given the following POM file where you have 2 dependencies like this, explicit dependency on Guava version 27 and another explicit dependency on Guava 28. Who is going to win? Is it going to be version 27, version 28, or does this result in a build error? Well, as it happens when we run this, if you invoke dependency tree, the first thing that you see there is this warning stating, looks like there is a problem. There is actually a duplicate dependency definition here from the point of view of the group ID and the artifact ID, but different version. This is something that is not supposed to be done, but Maven says, I will still let it pass. And it so happens that the chosen dependency is 28. The last explicit dependency that we have in the POM. Okay, last one. Here's the other thing. Here's the other question. Now let's move into transitive dependencies. Now I add Google Juice and Google Truth. Both of them have Guava as a transitive dependency in 1 hop. But the version of Truth, the Guava that Juice requires is version 25.1 Android. And the one that Truth brings in is 27.01 Android. So the question here is, given this POM file, which is a valid POM file, by the way, if I resolve Guava, which version will be chosen? Is it going to be version 25? Is it going to be version 27? Or is it going to result in a build error? Well, if I resolve this, it so happens that the chosen dependency is 25. Why is that? Because it was the first one found in the graph dependency. So let me show you a demo for that. Let's go back to the terminal and let's go into this example is transitive 1. Let me show you the POM file. It's exactly as the one that we saw in the slides, Juice first, Truth second. And if I resolve this, to Maven dependency tree, which by the way, the dependency plugin is not applied on my POM, but it's part of one of those well-known plugins that you would like to use. So you can invoke that goal just because you can invoke any plugin on a project, as we showed before. So let's look at that. Maven dependency tree, and it shows show that the result version is 25.1. What happens if we invert the definition of the dependencies? So let's see transitive 2. This is another POM file where I have Truth first and Juice second. If I do the same command before, dependency tree. Now the chosen version of Guava is going to be version 27. And that is why it's very important to figure out what is the order definition of your direct dependencies and your transit dependencies. There are ways around this. Let me show something else. Let's go back to the slides. So this is Robert Scholte. He is currently the chair of the Apache PMC. So that is the group that handles the, any decisions that have to apply to the Apache Maven project. And this is something that the Maven team is aware of. So he says that at the time when Maven dependency resolution rules were defined so many years ago, it was okay for just look at the location of a dependency in the graph, but not exactly at the version number. So what can we do to fix this? How can we make sure that regardless of in which order we define our direct dependencies, that our transitive dependencies have the version that we want? One option is to apply the dependency management block into your consumer POM. What you do in a dependency management block is pretty much say, if you happen to encounter a dependency whose group ID and artifact ID happen to be those, in this case, the ones for Guava, then the chosen version should be the one that is found there in the dependency block. So if I go back to the terminal and I have a POM file that looks exactly like the one that I showed in the slides, so that will be transitive version 3. Let's look at the POM. I have the dependency management block, and now it doesn't matter in which order I have, truth or juice, they could be inverted. When I do dependency 3 again, like so, then the chosen version will be, actually, oh, this one was version 29. The chosen version will be Guava 29, right? If I invert Google Truth and Juice, I will still have version 29. This is what I want. Another thing that you can do is apply the maven-enforcer-plugin, which provides a series of rules to verify what is the state of your build. And one of those rules is called require upper bounds. And in this way, you give Maven the capabilities of resolving dependencies using something that is very close to semantic version. So if we were not to use the dependency management block and you apply the enforcer plugin and apply the rule for required upper bounds, your build will eventually fail, telling you there are two versions, actually dependency conversions and upper bounds. It will fail telling you you have two versions of Guava, which are not necessarily compatible. So better fix that, and then you can turn into plugin management or some other, or an explicit dependency. I really love this particular tagline of Maven Enforcer, the loving iron fist of Maven, because the moment that you configure the Enforcer plugin in a build that is currently working, so you can create artifacts, that's fine. But you configure Enforcer plugin, you are gonna break the build very quickly, because there may be some things in your build that just happen to work for sheer coincidence. And the Enforcer plugin will tell you, better get fixed at that. I actually asked on a Twitter poll that is completely not scientific at all, who uses the Enforcer plugin, and I'm really sad that it's only a handful of people that use it, and actually the number of people that don't use it or they don't even know what the Enforcer plugin is or what can they do for them is actually high. If you're interested to know more about the dependency quiz, the URL is right in the slides. There were 509 entries and only 7 people out of these 509 got the 14 questions correct answer. There were 3 sections. The first 6 questions were on a POM file like the ones that you just showed before. It's just a simple POM with dependencies, transitive and direct. The second section adds a parent POM file, and the third section adds a BOM file. And you can see by the numbers that in the first section things are okay, except for question 1 and 5, which are the ones that I show you. For parent POM resolution, the number of answers, correct answers, are a little bit lower. And when BOMs comes in, there's definitely lower. And this is something that was kind of expected but surprising, because it tells me that not that many people know what BOMs are or how they can be used or understand the rules of BOM files. Here's another view of the same numbers. the thing that is really surprising on the first question is the number of people that thought that duplicate dependencies will cause a build failure. As I showed earlier, Maven actually outputs a warning, but allows you to continue. If you want to know more about the pitfalls and how to get out of Maven dependency hell, I certainly recommend you to have a look at this talk by Robert Scholte and Ray Sam, both Java champions. This was presented at JFL November 2019. The link down there has a link to the video and the slides and all the content. So this is pretty good. Any questions so far? All right.
Not until.
Perfect. So let's move on. Now, what is the typical command line or set of commands that we use when building projects with Maven? Most of you will probably answer Maven clean install, right? Well, this is something that should be avoided as much as possible. Because the first rule of Maven Club is you do not do Maven clean install. Obviously, the second rule of Maven Club is you definitely don't do Maven clean install. Because the third rule of Maven Club is you do Maven verify instead. And if you don't like Tyler Durden references, then let me give you this one. Rainbows on your build. What's going on with this? Maven verify is a phase. It's a life cycle phase, just like clean, as uncompile, and package, and many other. We have, I think the number of phases is 25, including the side phases. And there are no more and no less. Based on a phase, plugins can attach goals so that when you invoke compile or process resources or clean or verify or install, these plugins will invoke their goals and do the work that they need to be done. Now, it so happens that verify is a phase that is right before install. So when we invoke install, we actually invoke in verify after all. But what install does as an extra step is publish those artifacts that you have locally in your build into your Maven local repository. Now, this might not be seen as a problem because when you are building a multi-project build, you need those additional artifacts. You need your sibling projects. But the problem that arises is that first, I/O is slower, so you don't need to actually copy those artifacts. And secondly, what you actually want to do is just make sure that your build is working. Now, verify can do this for you because every artifact that you build is placed on the Maven reactor. What is the Maven reactor? So back then in Maven 2, Maven only supported single project builds. And there was a plugin out there called the Reactor Maven plugin that allows you to build multi-project builds. It was so good that the Maven developers decided when they reworked Maven 3 to add the Reactor feature as part of the core. That's why we have this name. Now, the other issue with Clean is that many of the plugins since Maven 3 are capable of using the Maven incremental build feature. Not all of them support it. That's a problem on the plugins themselves, but the platform, the Maven core allows plugins to do this. If you invoke clean, then those intermediate computations, those intermediate artifacts will be completely wiped out and you have to start over again. So that makes your builds run a bit slower. Robert presented at DevOps some of these things that happened throughout the years, the history of Maven 2 and Maven 3, and he actually wrote a very interesting extension. It's a little bit like in jest. It's called the Maven CI extension for the clean install that will warn you the first time you invoke clean install when actually you could have gone away with just invoking verify. And the second time that you invoke clean install, it will fail the build and will tell you, no, next time invoke verify. So it's just to remind you that things can be done in a different way, in a faster way. Now let's move on into multi-project builds. And if you do recognize these flags, that's good for you, but it's very likely that you have not seen this before. What does AM and PL do for you? When you are in a multi-project build, every project again is built inside the reactor. the reactor knows how many projects and what are the dependencies intra projects in order to things to be built. When you execute a goes, for example, compile, package, or clean install, but you know now that it should be instead verified, then this goal is going to be invoked for every single project inside the reactor. That is very important, and that is a key aspect. If you want to, instead, say that you have a multi-project with 50 projects or 100, I actually seen projects with 1,000, and you want to just build a subset of the reactor. This is where these two flags comes in. PL stands for project list, so you can give it a list of paths to the projects that you want to be build, and the goal that you specify or goals will also be invoked for every project inside that sub-reactor. But it's very likely that the project that you want to execute or that you want to invoke the goals on requires other sibling projects or other interdependencies, inter-project dependencies. So what do? You pass in the -am flag. This stands for also make. So with this, Maven says, okay, I'm going to run whatever project you have in PL, but if it has any other dependencies in its siblings and they're part of the reactor, then I'm also going to build them. How does this work? Let me show you a demo. Let's go back to the terminal and let's go here, one level up. This is Pasha number 1. So the root project, let's make sure that nothing is up my sleeves. See? So the files that I have here, this is a structure. There is a group, there is a root build POM XML, and have 4 projects, project 1, project 2, project 3, and project 4. Each one of them has its POM file, and there are a few Java sources. Great. Let's look at the root. The root has its GAT coordinates and 4 modules. So this says, if I were to build this from the root, and the reactor should contain 5 projects. The root and project 1, 2 to 4. Great. If I look at project 1, it's a simple POM file, no dependencies at all. If I look at project 2, I think it depends on project 1. If I look at project 3, I think it depends on project 2, which by transitive dependencies, it will bring in project 1. And if I look at project 4, I think that this one is a standalone project. Great. So you know that from the root, I can say compile, like invoke a go. And this tells me that it built 5 projects. This is the full React. Let's do a clean now. Let's go into, and now I just want to invoke project 3. So let's say I do PL for project list and pass in project 3 as the path. And I say, I want to invoke compile. So let's see what happens. And there is a failure because it cannot resolve its dependencies, project 2. Now, this is the reason why most people do Maven clean install. But let me show you what happens when I invoke this again, but passing -am for also make. In this case, the reactor is a smaller reactor. It contains project 3 because it's the thing that you want to build, but also all other dependencies, 2 and 1. And you may wonder, what is build here? Because build is the one that aggregates everything. Now, let's look at the source of project 3. This says it's as an executable. All right. And as you remember, the POM file does not have an executable plugin, but we know that we can apply the exec Maven plugin here, right? So what if I just want to run this command? Well, I want to run this project, so okay, that's easy. That is invoke exec Java, and we need to have this com acme main. So now we pass in exec main class equals com acme main, right? And this should work. Let's see. And we got a failure. What's going on here? Let's look at the error. The error says on the build project, it did not find com acme main. Can someone tell me what's going on here? Remember, there was one key element that I said is important. every goal that we invoke in the reactor will be applied to every single project in the reactor. Now, of course, the build root does not have any source code, so the main class cannot be found. But even if we're able to say by some magic, or ignore whatever is coming from the build, from the root, the same failure would apply in project 1 because project 1 doesn't have the main class, and the same thing happens in project 2 and any other dependency. So what can we do about this? Well, there is one way around this problem, and that is make sure that every project has the definition of the plugin that we're expecting. That's the reason why we use the plugin management block. And we can also deactivate the plugin by default for every project and only activate it for the project that we care about. Sometimes we will need to provide dummy values, for example, the main class. We'll have to have some weird value or undefined value, if you will, like text undefined, so that the compilation or the POM will work. But for the actual project that wants to be runnable, then we define the property. So let me show you what I mean by this. We go to this other project, partial number 2, and then the change that I have, this has the same structure. The only thing that I changed is the POM files. The root project now looks like this. I define 2 properties exposed by the exec Maven plugin, exec skip, a main class. So by default, the execution of the goal exec Java will be skipped. And the value for the exec main class is just gibberish. That class actually does not exist, but it doesn't matter. It's just text. It's not empty. That's the important thing. The parameter is defined. In the plugin management block, we define the coordinates for the exec Maven plugin, and we also apply the exec Maven plugin. That's it. Then let's look at project 1. This POM file remains the same. Project 2 remains the same. And project 3 is where we see a change. Here, we redefine the value for the property that needs to define the main class, so exec main class. And we make sure that we apply the Maven plugin, but making sure that the skip is set to false. If we were not to define this, then the execution will be completely skipped and nothing will happen. So let's do a clean here, right? And execute the command that we had before, this. Now, because I did a clean, I have to make sure that I have compile as well. So again, I'm just going to build a subset of reactor, project 3 and everything that it needs in order to be built. But I only want to execute project 3. So what's going to happen now is that the reactor says 4 projects, the root 1, 2, and 3, executes exec Maven plugin. No, it does not. It actually skips. For project 1, it skips. For project 2, it skips. But for project 3, it executes. So this is exactly what we want. Let's go back. Now, I already showed something like this already. The root build file that we have is actually an aggregating POM file. Now, aggregating POM files are those that define a modules section. And every module that you define contains the path to the project. Now, the standard convention is, or I don't know if it's exactly a convention, but the kind of like the standard layout is that for your sub-projects to reside on a directory that is adjacent to the POM that defines the modules. But if you were to have, let's say, a sub-projects directory, and inside them you have project 1 to 4, then you have 2 levels within the root and the sub-projects. Then the paths that you have to have will probably have to have sub-projects / project 1, sub-projects project 2, and all of them. And that would be it. But because we don't see that, most times you see a POM file inside the sub-projects directory saying, I will also define modules like project 1, project 2, and project 3. It's up to you to define how you want to have your POM structure. Now, typically, you also find the modules section in a parent POM. And the reason being is that it makes sense for a parent to define what is common to every other subproject that you find in a multi-project build. But make a distinction. An aggregating POM file does not necessarily have to be a parent POM file and vice versa. It's just by sheer coincidence that you find out there in the wild that this is true. For example, you have this file structure. Let's say base is any project that you want. POM could be any other project. Actually, the way that I would like to mention why it's a good idea to have just aggregating POMs without being parents is as, say base is your project and BOM is common slang and there's a bug in common slang. So what do you do in order to fix this? Well, download a copy of common slang, try to figure out how to fix the problem, fix it, publish it to a repository, could be local, could be some artifact, whatever it is. And then run the test in your project. Oh, it's not working. So you go back to common slang, fix it, and then check the test again in your project. And you do this as long as the thing is not fixed. Now, all the time, what will happen is we're pushing artifacts to a repository. But if we were to put an aggregating POM like this, then the only thing that you need to do in your project once you have made some changes to common slang is invoke Maven verify or Maven test. And that will compile common slang first because it's a dependency on your project, then compile your project and run the test cases. And that's how it works. I think they can skip this one. And BOM files. So a BOM file is a POM file like any other. But by convention, it has to have a dependency management block. It can have any other element that a POM file has, but typically we skip the build element and a few others. Because its most important aspect of a BOM file is its dependency management block. So once we have something like this, this is how we produce a BOM file. Then the way that we consume BOM files is by putting a dependency management block on the consumer POM and then import the BOM file. It's very important, it's key to remember that besides the gap coordinates, you have to define the scope of type import and the type property to have the value POM. Because by default, Maven will try to resolve the gap coordinates to a jar file. And for a BOM file, there are no binaries, there are no jars, there's only the POM itself. So once we do something like this, once we consume a BOM file that may define a set of dependencies that come together, and you probably have encountered a BOM file before. If you are used to Spring Boot, Quarkus, Micronaut, Helidon, Netty, Jackson, you have seen the BOM file before. So once we have imported a BOM file, and just by the nature of the dependency management block, as you remember from a few minutes ago, we can simply define the group ID and the active ID of the dependencies that we want to be included. And the version number will be resolved by everything that is available on the dependency management block. So in this way, what this thing is telling Maven is, you see that BOM file? That is a collection of dependencies with versions. Now, I want you to copy that information and put it in your own dependency management block so that you're ready. So whenever someone asks you for a dependency, check on that block. And if there is a match, it produces the actual version that you're waiting for. And that's how this thing works. So this is all that I have for now. And I know I could spend more time talking about Maven dependencies and things that I have found that are unique to Maven that work pretty well, and things that are kind of similar to Gradle and things that Gradle can do that Maven can't, and vice versa. But now I would like to open for questions. But actually, before I do that, let me remind you, I work for Oracle, so I need to show you this slide, and you're safe. So with this, if you have any questions, I will be very happy to take them.
Yeah, thanks, Andreas, for the call. So basically, there are a few questions. One is, how do you manage your project version within Maven when doing CI/CD, where any build could be the one that hits production?
Well, they are actually, it depends. So if you have a simple project, so it's just one project in your build, you could probably use regexes. You can use the release plugin, and I believe there's a couple of plugins that will externalize the version number and that will increment the version based on your SCM tags. Now, it gets a little bit trickier when you have a multi-project build, because it's not enough to change the version number on the parent POM or the aggregating POM. You also have to change it on every other child POM that includes either the parent, right? So this thing of doing a regular expression and changing POM files is across every POM file that comprises your build. Now for this, I believe there are a couple of plugins that can handle it. I personally don't use them. On my daily work, I don't have to deal so often with CI/CD pipelines. That's the only reason why I don't use it. It's not because they're bad. It's just it's not part of the use case that I have to solve.
Yep. There is another question for a new project. Why choose Maven over Gradle?
Good question. And a year ago, I would have said without hesitation, you go with Gradle. Nowadays, my answer, as everything, is it all depends. There are many reasons why you would prefer one over the other. If you and your team are familiar with Maven, then likely Maven is going to give everything that you want. If you encounter that there is some behavior that is missing, say you need something that for which there is no plugin, but there is a plugin in Gradle, but maybe have a look at that one. If the plugin that is available in Maven does not give you exactly what you need, and the team is not responsive or is very slow to reply, and so the things that it doesn't move as fast as you need, then you can either fork and try to fix it, or see if there are any other alternatives. I mean, there will be another plugin, or again, switching to the other build tool. The other reason why you might consider going with Gradle is build times. If the builds that you're running, I mean, you're running 20 builds a day, and every build takes 5 minutes to run, and say, that's not much a problem. Do the math. That's 100 minutes that you're spending building. Is that still good enough? If it is, then we're good to go. There's nothing that needs to be changed. But if you're building more and more every day, and your CI/CD pipeline also beats a lot, and time is of the essence, and your builds take longer than 5 minutes, no matter what you do, then it's likely that Gradle could be an option. Now, I say could be because if your team does not know the tool, they have to spend time learning the tool. There are a few things that are quite easy to jump from one to another, but be advised, be aware that appearances can be deceiving. Once you start getting into the gritty details of either of the two tools, you'll find some things like, oh, that's a gotcha. Oh, I didn't know that. Oh, documentation sucks, and so many other things. So it all depends.
Yep. There is one question is related to Enforcer. So the question is, so does the Enforcer plugin only check more than one transitive dependencies with same G:(A)? Are there more checks apart from that?
Yes, the Enforcer plugin performs a lot of checks that you can have. I think that there are like 20 odd something rules. So you can check that Maven is the right version if it's something that is important to you, and the correct Java version. So if you need to run on JDK 14, but you have 11 installed, then this can check that it will fail the build if it doesn't have the correct JDK, or there is a missing environment variable, or a Maven property, or what other thing is there. There are additional rules such as duplicate classes. You can have two different jars with different names, different group IDs, but providing the same class. This is common when you have something that is like an Uber jar or a fat jar. And that could cause trouble. This is actually some of the things that Maven and Ray go through in the session of surviving dependency hell. There is the dependency conversion, which makes sure that you don't have different versions of the same dependency, same group ID, artifact ID. And this will work for every dependency in your graph, not just one. And there are definitely a few other more that are not remember right now, but yeah, the Enforcer plugin, it's something that I will advocate strongly to configure on every Maven build out there. I wish and I hope that once Maven 4 comes out, we have the behavior of Enforcer baked in. Just like we did for Reactor from 2 to 3, I really wish we have Enforcer from 3 to 4.
Okay, now there is a question related to Maven release. So the question is like, Maven release does not work well with the Git, specifically with Maven release rollback. Is there any best practices or something?
Sorry, I didn't understand very much. So there's a problem with the Maven release and rollback?
Can I ask questions? It's Fahad Sheikh. That's the question I've actually asked. So with Maven release with Git, we've had issues in our teams where we are trying to use it that, you try to release an artifact, but with release you have two-step approach. You've got to prepare and then you have to perform. And we've seen issues where, for example, when trying to do rollbacks, the Git tagging gets into a bit of a trouble. Have you seen similar issues out in the kind of other, it's a question for you and the general audience over here, the experience with using Git and Maven release plugins? That's one question. And then the second question about branches, but if you could answer that, that'd be really useful. Thank you.
So I guess in this case, what the Maven plugin, and what I've seen most of the release plugins put in Maven and Gradle, they assume that you're always going forward. And in this case, you have a problem that you have to go back with the tags. Again, I don't use these plugins that often, so I don't know exactly how you will be able to configure. It may be the case that definitely someone has had this problem before. Now the question would be, does the Maven release plugin support this use case? If it does not, is there another Maven plugin that does? And in which case, then that would be the one that you need to configure. If there's nothing like this, then it would be definitely worthwhile reaching out to the Maven developers of that specific plugin and let them know that you have this use case and is there a way that can be fixed. And if there is something done in the configuration, then perhaps there's missing documentation. But if it's not, and there is some additional code that needs to be added, then it would be great if your team or someone else can help the Maven plugin team to fix it. Sorry, that's not something, the only thing that I have for now.
Okay. Thank you. And that's the second part to the question was that in terms of actually branching experience with Maven, so you have a master branch or your head branch, and then when people are trying to kind of developers will create their own branch and they want to kind of work on that. But, as the name of the versions, or at least for the project, will remain the same on the branch, you could have issues where multiple teams are kind of, working with it and their snapshots get overwritten, and
that's why you don't do snapshots.
Okay, so I mean, I think so. Would you say then because the general structure of Maven projects is like something version number and dash snapshot? So would you in your project you wouldn't use snapshots at all? How would you?
No, you would. But what I would advocate is to not use install, because what could probably be happening. I mean, I'm just theorizing because I've seen this in the past. Is that everybody has the same snapshot version. So it's version 1.011 snapshot, working with different branch, and they do Maven clean install and everything works locally. But if you do a CI/CD and you still have a snapshot and you push to your own local repository, to an organization repository, it could be Nexus, it could be anything else, right? This is when things get in trouble. Because so happens that there was one CI/CD worker running on branch X and another on branch Y, and both of them push artifacts that are incompatible but happen to have the same version number because they have a snapshot. That would be the problem. So if we can avoid that, if there is a way to do that, well, yeah, if you run verify on the CI/CD pipeline, because what you want to do is make sure that the build is working. And there is the use case where you want to do that, but you also need to publish artifacts for some other project out there to do some work. Now, does that other project out there need to consume snapshots? And that's the question. If they do, and you're using branching and the snapshots, then you definitely have a problem. If you do not, then it's just a matter of updating the process.
Okay, all right, thank you. And the final question was, will the slides be shared at some point?
Yes.
Okay, cool, thank you.
Do we have any other questions, Sunil? Any other more questions from the audience? All right. Well, thank you very much, everybody, for spending your time with me and your lunch time for those that are well, already have lunch. I really appreciate it. The slides will be available. I will send them to the LJC, and so everybody will be able to see them and do whatever you want with these slides. You can contact me on Twitter. There's my website. Anytime that you have any question, please let me know. I love to share information. I love open source. I also like to learn from others. So in this case, it seems like I definitely need to get more in touch with what the Maven release plugin does.